In this episode of Woodlands on the Web, we'll be talking about empirical formulas. Empirical formulas are important because they allow us to determine whether or not compounds are related. So an empirical formula is going to give us the lowest reduced ratio of all of the atoms in a compound. And for ionic compounds, that's already the same thing as the formula unit. So that part's pretty easy for us for ionic compounds, but for molecular compounds, sometimes molecules can be really big, and the empirical formula lets us understand whether or not they might be similar. So as an example, we have C6H12O6, and hopefully you guys recognize that from your previous science classes as glucose. And so if I reduce all of the subscripts in glucose, I get C1H2O1, or CH2O. Okay? If I look at the next formula, I also get CH2O. And so even though that is a 5-carbon compound, it's very likely that it's a 5-carbon sugar because glucose's empirical formula, which is a 6-carbon sugar, is CH2O, and so is the second compound. Now let's look at how percent composition data can be used to figure out what an empirical formula for a compound is. These are the steps listed here, but we're going to work them on subsequent slides in just a minute. So as the overall question, we have a compound that contains carbon, hydrogen, and oxygen. 54.5% of that is carbon, and 9.1% of that is hydrogen. The first step is to make sure that the total adds up to 100, and because we're going to assume that we have a 100-gram sample, then we're going to basically just change our percentage signs to the gram symbol. So we had 54.5% carbon, so we're going to change that to 54.5 grams. That means we have 9.1 grams of hydrogen, and if we subtract both of those values from 100, then we should see that we have 36.4 grams left over, which would correspond to oxygen. The next step is going to be to convert the number of grams that we have to moles. So remembering what we know about moles and mass, we're always going to use the molar mass to convert between grams and moles. Okay, so if we were to look at a set of train tracks or a factor label tree for this, if we start with grams, that means grams are going to go on the bottom and moles would be on top. So that means we're going to be dividing by the molar mass. So I'm not going to say that we have to show train tracks here, but we do need to understand where that comes from. So remembering that our molar mass for an individual element is the same as the molar mass off of the periodic table, that's where I'm getting 12.01 for carbon, 1.01 for hydrogen, and 16.00 for oxygen. Okay, when I do that division, 54.5 divided by 12.01 gives me 4.54. For hydrogen, I get 9.01. And for oxygen, 36.4 divided by 16 is going to give me 2.28. So in some cases, you might see this written as a mole ratio. Now that we have everything in moles, remember that the reason we use moles is because we're trying to put everything element-wise on the same playing field. So we're taking into account how big those atoms are and how much they weigh. In order to keep moving forward, we want to make some of our math easy, so we're going to try to make one of these numbers as the value 1. And the way that we do that is by dividing each of these working subscripts by the smallest value that we have available to us, which in this case is 2.28. Okay, so when we do that division, we get 1.99, 3.95, and the value 1. Because all of these numbers that we got for our working subscripts are very close to a whole number, we can basically just round them to the next whole number. So the empirical formula for this compound is going to be C2H4O. If you did have a fraction for one of those values, there's a guide up in the top left corner that helps you see what you can do as far as getting rid of those fractions. So if you have a number, though, that's an obvious fraction like that, then you do need to multiply it by its denominator so that you can get rid of that value. But for most of our examples, our numbers will come out to be something close to a whole number. And those are empirical formulas. I hope you learned something new today.